Hi guys, it's a one and only physics best teacher. So on this session, we'll be basically dealing with projectile motion, right? So as you can see here, they're saying John throws a ball vertically upwards with an initial velocity of 15 meters per second. And then they're saying ignore the effects of air resistance. And then the first question, what are they telling us to do? They're saying what is the magnitude and direction of the ball's acceleration? And then on number two, they're saying calculate the maximum height of the ball reaches above John's hand. Number three, they say calculate the time taken for the ball from the time of projection up until we will be dealing with number eight. So basically what you need to do, you need to remember that since this is projectile motion, uh, let's take an example whereby we're throwing the ball upwards. So it means to say, as we'll be throwing the ball upwards, so this will be representing the direction of the ball that has been thrown vertically upward, right? So let's say that is the ball. The ball was thrown vertically upwards, right? So you know that as the ball is thrown vertically upwards, it will also come a point where the ball reaches the stage where it comes back, right? So here I'm gonna use this as a red color. This is where the ball, this is the original standing where John is throwing the ball vertical upwards. So this ball here, the red ball, that's where basically the ball is exactly at John's hand. So one thing that you need to understand, since they're saying John throws a ball vertically upwards with an initial velocity of 50 meters per second, it simply means to say here, you're going to have what called a V initial. So your V initial, it will be what here? It will be 15 meters per second. V initial is going to be what? 15 meters per second. 15 meters per second. Meters per second. So this 15 meters per second, that is the initial ball. That is John having at his hand, right? And then they're saying ignore the effects of air resistance. So we know that as John throws this ball vertically upwards, there will come a time whereby this ball will reach its final air velocity, right? So just because of they're saying John throws a ball vertical upwards, simply means to say here we're gonna have what we call a V final. So if the V initial it was 15 meters per second when John was throwing the ball upwards, it simply means to say the final velocity of the ball, it will be what? It will be 0 meters per second. 0 meters per second. The reason why is because of, you know that when you throw the ball upwards, there will come a time whereby the ball will reach its final velocity, then it returns back to the original head, right? So that's what you need to have. And then they're saying what is the magnitude and direction of the ball's acceleration. So when they're saying what is the magnitude and direction of the ball's acceleration, this simply means to say, let me rather write my solution here. Okay, that is number A. They want us to write the magnitude and direction of the ball's acceleration. So the ball's acceleration, it will be what? 9.8 meters per second. So it will be 9.8, 9.8, 9.8 meters per second squared. So the reason why it's per second squared is because of its acceleration. So you can say downwards. So that will be downwards because acceleration, this is acceleration due to gravity is 9.8 meters per second downwards, right? So as we are continuing with number B, let's see what they're looking for on number B. So on number B, what are they looking for? They're basically saying calculate the magnitude, calculate the maximum height the ball reaches above John's head. So when they say calculate the maximum height, they simply want change in Y. They simply want what? Delta Y. So we're gonna calculate the magnitude of the ball's height. So that will be changing Y. So the reason why we say it's changing Y is because of in the vertical direction, we use displacement being changed in Y. So if it was a horizontal direction, it would be changing X. But this just because of it's a vertical projectile motion, we are only allowed to use what? Changing Y. So since they're saying calculate the maximum height, it simply means to say they want us to calculate the height, right? So they want us to calculate the height that is represented by delta Y. So it simply means to say with regards to delta Y, that we know that that is going to be our height. Our height is unknown. So it's going to be question mark for this one, right? And then we all know that you take upward direction as positive. So it's very important when you're dealing with physics to make sure that you elaborate direction. So let's take upwards being positive. So we take upwards being positive, and then we take downwards. We take downwards being negative. Downwards being negative. So this basically means to say, so remember that here I was speaking about the concept of you elaborating on the direction, right? So upwards we take it as positive, downwards we take it as what? As negative. So down we're gonna represent it as negative. So we now know that based on the information given, we are calculating what? We are now calculating the change in displacement that is represented by y. So this basically means to say this is what we are going to have. Continuing, do we know the initial velocity is? It means to say our v initial is given by what? Is given by 50 meters per second. So that is the one that you were given, right? So you write it 50 meters per second. And then do we know our final velocity? Yes, it simply means to say our final velocity. Let me write it with a different color just because of the ball will reach the final velocity of 0. So it means to say our final velocity, it will be 0 meters per second. So this, let me show you something. This final velocity is this one here, where the ball will be reaching, this one here, where the ball will be reaching the final velocity. Which then, what are we left with? We now know, hooray, we also have the acceleration due to gravity that is represented by what? That is represented by g. So you know that g, or rather a, because it's acceleration due to gravity, is going to be what? Minus 9.8 meters per second squared. 9.8 meters per second squared. So the reason why we say it's minus 9.8 is because of this is acceleration due to gravity. And since it's downwards, we know that downwards is going to be what? It's going to be negative. So that's why I'm saying negative 9.8. And then you're going to use the formulas, the formulas that we have in physics, right? So we know that the formulas that we have to calculate displacement, we normally call them equations of motions, right? So equations of motions, it will be what? We will be using this one, Vf squared, it's equals to what? Vi squared plus 2a delta y, changing y. Because as you can see here, they want us to do what? They want us to calculate the maximum height the ball reaches above John's hand. So the maximum height is the one that I was just elaborating here to say this will be our height here. This one that is represented by that delta y that is green in color. So that is our height. So we want to calculate the distance of that height. So after this, it simply means to say, now it makes our way too much easy. It simply means to say we substitute with the values that we are having. So our final velocity is 0. So it simply means to say you're going to say 0 and then you square it. Then you say equals to, then our initial velocity, we know that that is 15. So you're going to say 15 and then you square it, right? You square it and then it will be plus. Then you write the 2 from the formula. And then our A is acceleration due to gravity. That will be what? That will be minus 9.8. So you write minus 9.8. And then changing y, we know that that is representing delta y, the one that we're calculating. We can just write y there. And then continuing 0 squared, we know that is going to be 0. It's equals to. Then when you arrive here, it's a matter of you now taking your calculator and calculating, right? So as you are calculating, it simply means to say we're going to say 15 squared. So 15 squared is the same as 15 multiplied by 15. So that is 225. So here we are having 225. And then positive times negative is negative. Then you say 2 times 9.8. So 2 times 9.8, we are getting 19.6. So it will be 19.6 delta y. Apologies for my handwriting right there, delta y. And then we're going to take that negative 19. Since it's negative, we're going to transpose it on the other side. So it will change the sign to become positive. So we're going to have what? 19.6 delta y, changing y. And then it's going to be equals to what? It's going to be equals to 2, 2, 5. And then from here, we want y. So as we want y, it simply means to say we divide both sides by 19.6. So we're going to divide by 19.6 both sides. So the reason why you divide by 19.6 both sides is because of let's say what I do on the left-hand side, I also do it on my right-hand side. And then from here, you have an understanding that this 19.6 will cancel 19.6, and then you'll be left with what? You'll be left with simply y. It's equals to, then it's going to be 225 over 19.6. So we're going to say 225 divided by 19.6. So we are getting what? Let's see what are we getting. So I'm getting 11,47479 m. So remember, it's displacement. So the SI unit should be meters. But mind you, you can write it like this. Therefore, y, or change in y, it's equals to what? That is 11,5. So it will be 11,5 meters. So it simply means to say 11,5 meters, that is your displacement. So this 11.5 meters that we got here, that represents the displacement, is the whole thing color, right? And then now we go to number 2. We go to number 3. That's saying calculate the time taken for the ball. Calculate the time taken for the ball from the time of projection. When that's saying from the time of projection, that's simply telling us from the time of it being released from John's hand, right? And then to reach John's hand again. So it means to say we calculate the entire time. We calculate the entire time. So when that's saying from the time of projection, here at the hand, that's where the ball is being projected from, right? So this is the original onset of projection here. And then that's saying up until it reaches John's hand. So when that's saying up until it reaches John's hand, so here, this is where actually it reaches the hand again, right? So you can actually see, just a second, that's where it reaches the hand again. So you can actually see that we want to calculate the time taken for the entire movement of the ball's projection, right? So as we are calculating the entire projection of the entire time taken, it simply means to say we are simply looking forward for the total time taken. So this is how we're going to calculate the total time taken. So this is how we're going to calculate the total time taken. Let me utilize the space that we are having here. So let me just utilize this space. So we are on number 3. So that is number 3. So we want to calculate the time. So it simply means to say we are calculating the change in time total. So the change in time total. So the change in time total of the entire projection of the pulse movement, we are calculating it. And then it simply means to say the V initial, it will be 50. V initial, it will be what? It will be 50 meters per second. 15 meters per second. So V initial, it will be 15 meters per second. Right? And then we are also having G. Remember, G or A, I like saying G because it's acceleration due to gravity. So we can rather say A based on what we were taught. A is equals to minus 9,8. So it's minus 9,8 meters per second squared. Right? And then it simply means to say we are, and this one you need to be very careful, is changing Y. So delta Y, let me show you something. Because if I'm not going to explain this, most of you I'm taking for ball's projection. It simply means to say we are calculating. You know that the ball has moved. This is the entire movement of, since that is the entire movement of the ball, we don't have the height from the hand going upwards. So since that's saying calculate the time taken for the ball, this is the time of projection from here up until the displacement. So since you can be able to see that, it's very important that you remember that. So it simply means to say we are not going to have displacement, right? So with regards to the displacement, I'm going to use 0 meters because we don't have displacement in that regard. And then the formula for the equations of motion that we're going to use the formula that says delta y, change in y, it's equals to what? It's equals to V initial, change in time, plus half A, changing T squared, changing time squared. So we're going to use that. So it's very important that when you write your data, you substitute the information from the data. make your work to be much easier in it. So we can actually see that here we are having what? We are having our delta y that is going to be 0. It's equals to, so our v initial is 15. So it simply means to say we're going to write 15, right? And then can put it in brackets to make your work to be much neat. And then here we are calculating the time. Since we don't know the value for t, here it means to say it will be t. You can write t or you can write change in t, still going to be correct. Then you write plus half, right? And then let's see the acceleration. Its acceleration due to gravity, that is going to be minus 9,8. The reason being is because of its downwards, we choose the direction. Downwards, we choose it as negative, right? So that's why it's negative 9.8. And then that is going to be t squared. And then here, it will be, you can write 0 to make your work to be much neat. So that is 15t, right? And then positive times negative, it's negative. And then 1/2, which is 0,5, when you multiply it by 9,8, you're going to get 4.9. So it will be minus 4.9 times squared, t squared. So as it's like this, it's very easy now to solve, right? So to those who did maths at school, you can write it like this. You can write it like this if you want to see it properly. So you can just say 15t minus 4,9 t squared, it's equals to 0. So here you can see that we're having t as a common factor. I'm going to take t as a common factor. Then I will be left with what? With 5, with 15, because I only took a t as a common factor. So I'll be left with 15 minus what? 4.9 t minus 4,9 t. Then you say equals to 0. So as you apply FOIL method, when you are saying t times 15, it should give you 15t, right? So let's continue. And then when you are saying t times minus 4.9t, it must give you minus 4.9t squared. So you can actually see based on what you are having here, it will be t, it's equals to 0. T is equals to 0 seconds, because its time is measured in seconds. Or, and then here we'll be having what? 15 minus 4,9t, it's equals to 0. Then you're going to say 15, right? 15. Then that is minus 4.9. When you take it to the other side, it will change the sign to become what? 4,9t. So you're going to say 4,9 multiplied by time. And then when you arrive here, let's say it's already on the left-hand side, to also do it on the right-hand side. So I'm going to divide by 4,9 both sides. I'm going to divide by 4,9. And then from here, you remember that 4,9, it cancels 4,9. And then as you proceed, you can see that you'll be having 15 over 4,9, it's equals to time. So if you want to write it properly to make your work to be much neat, you can just conclude and say, therefore, time, it's equals to 15 over 4,9. And then we all know that that is going to be approximately what? So let's see, 15. You press your calculator, you say 15 divided by 4.9, 4,9. So that is 3,06. 3,06. So it will be 3,06 seconds. So remember, this is time, right? And then this 3,06 seconds is the entire time, is the time taken for the ball to be released from the point of projection up until it reaches the hand again. So it's when the ball was released from the hand up until it reaches the maximum height, then up until it comes back from the point of projection, the time taken, which is change in t total. That's why I said change total. So the change in time total there, what do you have? Change in time total. We're going to have what? We're going to have it being 3,06 seconds, guys. 3,06 seconds. So that is the change in t. And then from there, what do you need to do? And mind you, so the only one that we are going to take is this one. Is this one. We're going to take only this one of 3,06. Reason being is because of this one, we know that time it cannot be 0 seconds. Do you see? So this one, it doesn't have solutions where t is equal to 0.6, where t is equal to 0 seconds. So the only one where we are having a solution is 3.06 seconds. So we're only going to take that one, right? So make sure that you follow the way I'm writing. I know my handwriting is not a bit visible, but try your level best to make sure that you write notes as well. So make sure that you see how I'm moving so that you don't get lost. So myself, I'm going to only utilize the space that I have. So you on the other side, you just write them properly from one followed by the other, right? Myself, I'm done. Let's see on number what? Number 3, we're done. Number 4, calculate the velocity of the ball. Calculate the velocity of the ball as it reaches John's hand again. So they want us to calculate the velocity of the ball as it reaches John's. Calculate the velocity of the ball as it reaches John's time again. I'm going to only utilize this space. So here we are on number 4. So when they say calculate the velocity, it simply means to say they want the V final. So the V final is the one that we don't know. I'm going to say question mark. And then just because of you now know that the changing time total, the total time for the ball to reach Johnson again, we got 3,06. You can now write that 3,06 seconds. We're going to use it. And mind you, if this 3,06 seconds that represent the time was wrong, then it basically means to say your final velocity as well will be wrong, right? And then we all know that we have initially the initial velocity of the ball that is being released from John's hand. That was what? 15 meters per second. So it simply means to say I'm going to write 15 meters per second. So that is the one relation due to gravity. That is going to be 9, minus 9.8 meters per second squared. So that is what we are having, right? And then from there, that's when basically you can do what? You can be able to calculate. So now let's try to calculate. So we're going to use the formula of the equation of motions. V final is equals to what? It's equals to V initial plus A change in time. So now since we calculate the V final, it will be V final. It's equals to, now we substitute your V initial, it's what? It's 15. So we're going to say 15 plus, we have acceleration due to gravity, yes. That is minus 9.8. Make sure that you put it inside the bracket so that it makes your work to be much neat. Minus 9.8. And then multiply by time, which is the total time. That is why I wrote a change in T total. That is going to be 3,06 seconds, right? So this will be V final. It's equals to, then as you have here, so that is going to be what? That is going to be 15. Positive times negative, that is going to be minus. And then now let's calculate 9.8 multiplied by 3,06. So I'm getting, look at this, I'm getting 29,288. So it's roughly 30. You get to see that. And then this here, it's going to be V final. It's equals to 15 minus 30. That is going to be what? Negative 50 meters per second. Its velocity, it must be meters per second. But we are not done. I'm going to say, therefore, V final. Remember, when you're using physics, it's very important that you do what? You can see here, we got negative 50. So that negative, it's what? That negative it represents direction. And get it's negative. Let me show you. Since it's negative, this negative here, we can see that negative simply represents downwards. You get to see. So it's simply V final is equals to what? 15 meters per second downwards. This is 100%. It's a distinction on its own. Downwards. That is a distinction. So see, the reason why I'm saying it's downwards is because of, as you look at also your diagram. So the final velocity that we're actually calculating now, this is the final velocity that rests here. So that is going to be V final. It's equals to what? It's equals to minus 15 meters per second. So even if you don't say minus 15 meters per second, you can just say that negative is simply represent that we're speaking about downwards, right? And then after that, they're saying number 5, draw a velocity versus time graph for the complete motion of the ball. So when they're saying draw the velocity time graph for the complete motion of the ball, describe the shape of the graph in weights. So this is how I'm going to try to draw it here. So here we are having number 5. So that is we want to get the velocity time graph. So that is velocity time graph. So always, as you are working with time, just the second graph. So always, as you are working with equations of motion, You must remember that a velocity time graph is a straight line graph. So since it's a straight line graph, it simply means to say, as I will be drawing it, we'll be having a straight line like this, right? And then that straight line, you must make sure that you remember this. So we're going to have two movements under this velocity time graph. These two movements, they include the direction when the ball is being projected upwards up until it reaches the original hand of John. So we know our V, this, remember, is the y-axis, right? As well as this one, it represents, you must remember this. If they never taught you, I'm now teaching you. So the x-axis represent our time. And then our time is always in seconds, right? And then this one, the y-axis represent velocity. Velocity, you must remember that that is going to be in meters per second. Meters per second. Right. So our initial velocity, we know where it was 15. So since it was 15, here we're going to have 15 meters. And then remember, we also have our final velocity that was negative 15. So negative 15 it was here. So that is the final velocity. And mind you, the total time for the ball to reach John's hand, it is what? It is 3,06. So that's why they said we must calculate the total time taken. So here it will be 3,06. 3,06. So I'm going to divide 3,06 by 2. When I'm dividing 3,06 by 2, you're going to get what here? That will be your middle point. That is going to be 1,53. 1,53. So there is no, I'm dividing it by 2. Let us go up there. I want to show you something. So if the time taken for the entire ball movement, it's 3,06, it simply means to say, as the ball it is going upwards, up until it reaches this maximum point here, the time taken is going to be 1,53. The entire time taken to be 1,53 seconds. Even if you didn't calculate it, it will be 1,53 seconds. And then from here up until the ball goes down again to reach John's hand again, it's going to be up until it reaches here. It's going to be another 1,53. So you can actually see that if you say 1,53 plus 1,53 seconds, you're going to get the total time taken, which is given by 3,06. That's why they ask you. So that's why there I'm dividing it by 2. I'm dividing it by 2. So we're going to get 1,53. So now it simply means to say you must have a straight line. So that straight line, you move like this. So remember that you make dotted lines, even if they're not that visible, as long as the person who's marking can be able to write. So you're going to draw that velocity time graph here. So it should be a straight line. It should be a straight line, guys. It should be a straight line. So it will come from here, passes there, then it should, something like that. So that will be your velocity time graph, right? So your velocity time graph, it's a straight line graph. So your velocity time graph should be a straight line graph. So reason being it's a straight line graph is because of it shows us the direction of the upward movement when the ball is projected upwards, as well as the direction of the downwards ball as the ball is projected to the downside.